Hello, and welcome to COMSI 127, File Processing and Database Systems. For this particular lecture, we will talk about relational algebra. Before we continue, let me just give you an outline of what to expect from the lecture. Number 1, we will first define what relational algebra is and provide you of motivations or reasons why we need to study this topic. Number 2, we will define and give you the 3 basic operations of relational algebra. In particular, they are the project operation, the select operation, and the rename operation. Number 3, we will give you some examples of how to create and express your queries written in relational algebra form and in SQL form. So, are you ready? Let's begin! What is a relational algebra? Relational algebra refers to the basic set of operations for a relational model. It allows or enables a user to specify basic retrieval requests. For example, if there is a relation named student with attributes student number, student name, and student degree program, it's possible for us to make these following requests. Number 1, say, retrieve the name of all students whose degree program is BS Computer Science. Or retrieve the name and student number of all students whose degree program is BS Development Communication. Or say, for example, retrieve the name and degree program of the student whose student number is 2014-12345. Now that we know what relational algebra is, we now ask, why do we need to study relational algebra? We provide you of 3 reasons why you need to study it. First is that it provides us the formal foundation of relational model operations. Second, and I think the most important reason, is that it serves as the basis for implementing and optimizing queries for relational database management systems, or RDBMS. Third, but not the least, is that RDBMS's core features and functions rely on relational algebra operations. The first operation that we will discuss is the project operation. The project operation allows us to limit the number of columns or attributes in the resulting table or relation. It is represented by the symbol pi, and its syntax or form is as follows. The project operation symbol, represented by pi, followed by a list of attributes a sub 1, a sub 2, up to a sub n, followed by the relation, represented by r. So here, we have attributes a sub 1 up to a sub n being the attributes of the relation r. And relation r could represent a set of relations that are, or that can be joined together by a relational algebra operation. Say, for example, a joint operation, a union operation, and other operations that we will be discussing in the lecture. To give us a working example of how project operation works, let us use the student relation as an example. Suppose that we have a student relation with the following attributes: student number, student name, and the student degree program, with the student number being the primary key. Now, suppose that we want to see a list of students that contain only their name. So how do we do that? So the relational algebra for that would be project, followed by student name, followed by the name of the relation, which is student. Are you following? So another example would be, suppose that I want to see a list of students containing their student name and student number. So how do we do that in relational algebra? To do that, all we have to do is to state the expression project, followed by the student number, then the student name, and the name of the relation, which is student. Now, let's try to solve this problem together. How about if I want to see a list of students containing only their names and their degree programs? So how do we do that in relational algebra? So, if you tried to answer that question, the answer would be project, followed by the name of the attributes of concern, which is the student name and the student degree program, followed by the name of the relation, which is student. So, are you able to follow and understand project operation? If you were able to follow that, then we can proceed to the next operation, which is the select operation. The next operation is the select operation. If the project operation allows us to limit the number of columns or attributes in the resulting table or relation, the select operation allows us to limit the number of rows or tuples in the resulting table or relation. It is represented by the symbol sigma, and its syntax or form is as follows. The select operation symbol, represented by sigma, followed by a condition or list of conditions, followed by the relation, say for example, R. The condition or list of conditions help us filter which particular row or tuple are to be included in the resulting table. If there are more than one condition to be imposed on the relation, they must be concatenated or joined by Boolean operators and or. Also, similar to projection or project operation, the argument R can be a single relation or multiple relations that are joined together by relational algebra operations. Say for example, a join or a natural join operation. To give us an example of how to use select operation, we go back to our earlier example of the student relation. Now, assuming that we have the same set of attributes, student number, student name, and student degree program, if we want to see a list of students whose degree program is BS Computer Science, then we can express that in this form. The select operation symbol, which is sigma, followed by the condition, which is the degree program should be BS Computer Science. So we state that as student degree program equal to BS Computer Science, followed by the name of the relation, which is student. Now suppose that we have another example. Suppose we ask, I want to see a list of students or student whose degree program is BS Computer Science and whose name is Juan de la Cruz. How do we do that? So we express that as follows. The select operation symbol, which is sigma, followed by the name of the degree program. So we specify degree program equal to BS Computer Science, followed by an AND operator, and then followed by another condition or another limiting filter, which is the name of the student. So we include the attribute student name equal to Juan de la Cruz. So that would be student degree program equal to BS Computer Science and student name equal to Juan de la Cruz. And then, of course, we have to include the name of the relation, which is student. Now, it's time for you to answer this question and try to see if you were able to understand the select operation. Suppose that we want to see a list of students whose degree program is BS Computer Science, and say, for example, their student number is 2014-12345. How will you do that? Now, if you were able to follow the examples, then you might have an answer similar to what is shown here on the board. So, if you were able to understand select operation, we can now proceed to rename operation. From select and project operation, we will now proceed to rename operation. The rename operation is represented by the symbol row, and it allows you to rename the attributes or columns of a particular relation or table, or rename the relation or the table. And it comes in three forms. If you just want to rename the name of the relation or table, all you have to do is specify sigma, followed by the new name of the relation, and then the name of the old relation or table. Say, for example, you want to change the attributes of the relation rather than the name, all you have to do is to specify row, followed by the attribute list of the relation, the new attribute names of the relation, and then the name of the relation. Say, for example, R. If you want to change both the name of the relation and its attributes, all you have to do is specify row, followed by the new name of the attribute, or I mean the relation, followed by the new name of the attributes of the old relation, and then the old relation. So say R. It is important to note that when you change the attributes of a relation, the change of attributes or the change of name of attributes are matched against the old names of the attributes. Meaning to say, the first attribute that you specify in the row operation should match in the first attribute of the old relation. So we follow here order, and they are changed sequentially. Okay? So as an example, going back to our student relation that we have been using earlier, if we have here student and I want to change the name of student into something like student underscore BSCS, because I realized that the contents of the student relation are all BSCS students, then I can specify a relational algebra expression, something like row, followed by student underscore BSCS, followed by student, which is the name of the old relation. If I want to change the name of the attributes of student, dropping all the student component of the attribute name, say for example, from student number to just number, student name to just name, and student degree program into just degree program, I can specify that using this statement or expression, row, followed by name, if name is the first attribute of the student. So let's assume that name is the first attribute. Then followed by the student number. And then we have here the degree program. So we have name, number, and we have degree program. Followed by the name of the relation, which is student. If you want to change both the relation and the attribute, I'm trying to say that if I want to change the names of the relation and the attributes of that relation, then I can specify something like row, followed by the name, the new name of the relation, which is student, say student underscore BSCS, and its new names, new attribute names of the relation. Say we have name, number, and degree program, followed by the old name of the relation, which is student. Now that you are familiar with the rename, project, and select operations, it's time for us to present to you more complicated examples. We will still stick with our working relation, which is the student relation, with attributes student number, student name, and student degree program. Suppose that you are asked to produce the names and the student numbers of students who are under the BS Computer Science degree program. How will you do that? Understand or realize that this particular problem requires you to use both the project and the select operation. So the first thing that you have to do is to first select from the relation student all the students who are under the BS Computer Science degree program. So first, you have select student degree program equal to BS Computer Science, from the relation student. Now, at this point, you are sure that the resulting table will produce only students under the BS Computer Science degree program. And from there, all you have to do is to project the student numbers and the names of those students. So it means that it's possible for you to provide nesting of operations in a relational algebra. Another example, suppose that we want to see the name of the student whose student number is 2014-12345. How will we do that? So we can do that by first selecting the name or selecting the student with student number 2014-12345. So the resulting table would contain the columns student number, student name, and student degree program. And then from there, we just have to select the name of the student. To wrap up the session, we were able to discuss what relational algebra is and provide you of motivations why you need to study relational algebra. We were also able to identify three fundamental operations: the project operation, select operation, and rename operation, and provide you of examples of how to use them. Understand, however, that we were not able to discuss the properties of those operations. We were also not able to discuss other operations under relational algebra. Those are to be discussed in the succeeding video lectures for this course. For the meantime, we have provided you of a link of the lecture slides for this particular session. Also, we have provided you of a link for the assessment quiz which you may want to take in order to test whether you have understood the concepts presented here. We do hope that you enjoy studying ComSci 127 and in particular this topic. So, see you next week for another video lecture. Bye-bye for the meantime.